This is the Semester 2 final exam review for problems 31 to 38 in the review packet, plus performance assessment task number 3. Problems number 1 and 2 will be done in another video. Number 31 gives you a graph, and it says, what is the standard deviation of the normal distribution? Well, if the graph is normally distributed, that means the mean is smack dab in the middle. So the mean appears to be 656. So one standard deviation, this is one standard deviation, to the right is 696. The standard deviation is going to be the difference between these two. So really, all you have to do is subtract them to find out the standard deviation is 40. In number 32, it says a normal distribution has a mean of 600. I'm going to write my 600 right here. And the standard deviation is 30. That means one standard deviation to the left and right. This is going to be at 630. And then this is going to be at 570. So a second standard deviation to the left and right. This is going to be at 660. And this is going to be at 540. And a third standard deviation to the left and right is going to be at 690 and 510. So if you think about a normal distribution curve looking something like this, where the mean is in the middle, the normal distribution curve says that 34% of the data is one standard deviation away from the mean. So it's 34% of the data should be one standard deviation to the left, and 34% of the data should be one standard deviation to the right. Another 13.5% of the data will be two standard deviations to the left and right. Another 2.35% of the data will be 3 standard deviations to the left or right. And then we discovered that the last percent was 0.15%. So we want to know what the probability that a value selected at random is at most 540. Well, 540 is here, and we want at most. So what you do is you add those standard deviations. So 2.35 plus 0.15 is going to be 2.5%. So 2.5% of the data should fall below 540. Number 33, scores on an exam are distributed normally with a mean of 78 and a standard deviation of 10. All right, so one standard deviation is going to be 88 and 68. Two standard deviations is going to be 98 and 58. 3 standard deviations are going to be 108, which is probably not a score somebody's going to get, and 48. And then here is my normal distribution curve. All right, so I'm going to go fill in the percentages. 34 and 34, 13.5, 13.5, 2.35, 2.35, and 0.15, 0.15. It now says, out of 250 students, or tests, about how many students score above 98? Well, in order to figure out what percent of the students are going to score above 98, I'm going to add these two numbers. Okay, so 2.35 plus 0.15 is 2.5%. But that's not the answer to the question. The question says, out of 250 tests, how many students will score above 98? This just tells me what percentage of the students should score above 98. So if there are 250 students, we're going to multiply this by 0.025 to find out how many students score above 98. And the answer is going to be 6.25. Now, you can't have 6.25 students, so we're going to say that it's either 6 or 7 students are going to score above a 98. Number 34, a hardware store sells bags of mixed nails. The number of nails of a given length is distributed normally with a mean length of 7 inches and a standard deviation of 0.05 inches. About how many nails in a bag of 150 are between 6.95 and 7.05? Well, if you go one standard deviation to the left and right, here's your 7.05 and 6.95. And we already know that when you go one standard deviation either way, it's 34% on either side. So, between these two, it's 68% of the nails should be between 6.95 and 7.05 inches long. But that's not the answer to my question. The answer to my question is how many nails in the bag of 150 will fall in that category. So you have to multiply 150 times 0.68. And we're going to find out that it is 102 nails out of the 150 should fall between 6.95 and 7.05 inches long. Number 35, what is the inverse of y equals log x? Well, first of all, if you don't see a base, the base is 10. Now, we have this little formula, the log base b of x equals y, if and only if b to the y equals x. So if I have an equation in log form, I'm going to rewrite it in exponential form. So b is always the base. The power you use is always the other side. Oops. And that's going to equal this number. Except for an inverse, the other thing we do is we switch x and y. So for an inverse, we always switch x and y. And I guess the problems I had done in class, I had switched x and y first and then solved for y. In this one, I switched it at the end. It doesn't matter. You could switch it at the beginning, switch it at the end. So I could have done this. I could have done x is equal to the log base 10 of y and then rewritten it, and I would have gotten the same answer. In number 36, we want to identify the function y equals 1/2 times 3 to the x as either exponential growth or decay, and identify the y-intercept. All right, so in order to determine growth or decay, you always look at this number. When you have y equals a times b to the x, as long as a is greater than 0. B, if it's greater than 1, will be growth, and if it's between 0 and 1 will be decay. So in this particular problem, it's growth. The y-intercept is always 0, a. So in this case, the y-intercept is 0, 1/2. In number 37, we want to describe the transformation that changes f of x into g of x. So f of x is 1/3 to the x. This is the parent function. So we want to figure out, well, what do we do over here to transform it? A negative in front of a function always reflects over the x-axis. And the other thing that's been done to this graph is we added 4 to the input. When you do that, it moves the graph to the left 4. So these are the transformations. So for an equation y equals b to the x, negative b to the x reflects over the x-axis. B to the x plus k. If it's positive k, the graph goes up, and if it's negative k, it goes down. For y equals b to the x minus h goes to the right h, and x plus h goes to the left h. And those are your transformations, the same transformations we did with quadratic equations and with radical equations and absolute value equations. In problem 38, I'll show you an easier way of solving this problem in pre-calculus. But for right now, the way we're going to do this problem is I'm going to think about it like an algebra problem. I'm going to add 1 to both sides. And I get 2e to the x equals 8. And then I'm going to divide by 2, so I get e to the x equals 4. The easiest way to do this problem is to put e to the x in y1 equals, 4 in y2 equals, graph it, then find the point of intersection, doing second trace 5, enter, 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 and you should get x is about 1.386. This is performance assessment task number 3, where it gives you f of x is equal to 7 over x minus 2. In part A, they want you to identify the constant of variation. Well, this is the equation y equals a over x minus h plus k, where h moves the graph left or right, k moves the graph up or down, a compresses or stretches the graph, but it turns out that this is really just an inverse variation equation. Inverse variation was the one that said y equals k over x. So a is really k, your constant of variation. So your constant of variation is 7. In part B, they want you to identify the domain. Well, when you have a fraction, remember that the one number you can't have in the denominator is 0. So the only number that will make the denominator 0 and thus undefined is x equals 2. So the domain is that x cannot equal 2. In part C, it says, write an equation for any vertical asymptotes. Well, vertical asymptotes are those things called non-removable discontinuities. Can you cancel x minus 2? No. And since you can't cancel it, and it's non-removable, let's do this in a different color, non-removable, that the vertical asymptote is really what you get when you set the denominator equal to 0, which is x equals 2. And then in part D, they want you to graph it. If you know the vertical asymptote, which is at 2, and you know that the horizontal asymptote is also 0, and they didn't ask me that question, but I'm telling you it is. The reason is because the degree of x in the denominator is bigger than in the numerator, because there's no x in the numerator. So I know there must be an asymptote here. Therefore, the graph is going to look like this. But you probably could have used your graphing calculator for help.